Hello, my name is Harrison Butker, and for the Test 2 wrapper, I will be going over problem number 1. The problem states, there is no general analytical solution for the motion of a gravitational system consisting of more than two bodies. However, there do exist analytical solutions for very special initial conditions. Here are four stars, each of mass m, which move in the plane of the page along a circle of radius r. Part A says, calculate how long this system takes to make one complete revolution. To begin, we first need to think about the forces acting on our system. The first diagram shows that the only forces acting on star 1 are the gravitational forces from the three other stars. The second diagram shows us how we calculate cosine theta, which we will need when solving this problem. The diagram also shows the distance between star 1 and the other three stars. To solve the problem, we need to know the equation F perpendicular is equal to the momentum times velocity divided by the distance from star 1 to another star. We also need to know the equation T is equal to 2 pi r divided by velocity. We are first going to solve F net perpendicular, which is just equal to F net since the velocity of the four stars is constant. The equation for gravitational forces between two objects is g times one mass times the other mass divided by the distance between the masses squared. From the diagram, we know the distances and can just plug them in and then reduce. We find that F net is equal to g times m squared divided by r squared times 1/4 plus 1 divided by the square root of 2. Since we know that F net perpendicular is equal to momentum times velocity divided by distances between two stars, and momentum is equal to mass times velocity, we can just solve for v squared and then plug v squared into the equation t squared equals 2mr squared divided by v squared. Therefore, it takes 2 pi r divided by the square root of gm divided by 4r times 1 plus 2 square root of 2 to complete one revolution. Part B says, unfortunately, the configuration of four bodies moving in a circle is very unstable. A short time later, one of these bodies is observed to move at constant speed along the path shown in the diagram below. On the diagram, draw a vector representing the net force on the object when it is at location A and B. Since velocity is constant, F net is equal to F net perpendicular. The tricky part is figuring out which net force on the object has greater magnitude. Is it at position A or position B? Since F net perpendicular is equal to mv squared divided by r, and position A is closer to the forces acting on it than position B is, the net force on the star at position A will be greater than the force on the star at position B. Thank you.